The aim of this procedure is to demonstrate a transfer printing-based microassembly termed micro-masonry for three-dimensional additive micromanufacturing. This is accomplished by first preparing silicon or gold micro-objects, called inks, on donor substrates such that they are suspended on patterned photoresist supporters. The second step is to precisely align an elastomeric microtip stamp on an ink and apply a preload, a predefined force, on the stamp to form an adhesive contact area in between. The stamp is then rapidly retracted to retrieve the ink. Next, the stamp and the retrieved ink are transferred to a receiver substrate, where the ink is gently printed on the target area with the small preload. The stamp is then slowly retracted, leaving the ink on the receiver substrate. The final step is the rapid thermal annealing of the receiver substrate to bond the printed ink and the substrate permanently. Ultimately, this transfer printing procedure is repeated until a desired 3D microstructure is completed. In this case, a micro teapot is fabricated solely through micro-masonry to demonstrate its capability.
The main advantage of this micro-masonry technique over conventional monolithic microfabrication is that it can create heterogeneous three-dimensional microstructures in a very simple way, as children play with Legos, which would be otherwise very challenging to achieve.
Visual demonstration of the method is very critical due to its parallel steps. Visually observing this technique should clarify any ambiguities that the viewers may have.